Alright, in this video, everybody, what we're going to be talking about is function symmetry and how that's going to work. Alright, so when you think of symmetry, hopefully you know what symmetry is, where things are perfectly reflected across a line. So this is like, this would be reflected across a y-axis going up and down. We also have functions that are reflected across, say, the y-axis. So right here you can kind of see that this graph right here, no matter what I do, is reflected across the y-axis. So what does that mean? If it reflects across the y-axis, it's considered to be an even function, if it's symmetrical with respect to the y-axis. So right now, it says which graphs represent even functions. Well, this is not symmetrical about the y-axis. This one appears to be symmetrical about the y-axis. This one also appears to be symmetrical about the y-axis. And this one also appears to be symmetrical about the y-axis. So we're going to hit check. Hey, it looks like we got it all right. And that's what it's asking you to do. So what does that mean algebraically? All right, so if you have a function and it's f of x, and you plug in f of negative x into that, and it ultimately comes back to being the original function, you know it's going to be what's called an even function. So let me explain how that works, because this right here, it says if f of x is equal to, if f of negative x equals f of x for all possible values of x, it's considered to be even. So let's just basically take a parabola, okay, which is an even function. We have a parabola that goes right, not all parabolas, but this parabola it goes through 0, 0. All right, and we put f of x equals, say, x squared. All right, and we could even put plus 2. So it does not necessarily have to go through 0, 0. But so let's say I was the original function, and I'm going to say, what is f of negative x? So what I'm going to do is I'm going to put a negative x right there. I'm going to square it, and I'm going to put plus 2. Now a negative times a negative is a positive, and x times x is still x squared. So here's what you notice. When I say, what is f of negative x, it gets me back to the original function that I already had. Nothing has changed, because in a table of values, okay, all even functions, this is what happens. If I had a table of values, I'm going to call this x, I'm going to call this y. If I have an x value and a y value, I'll have a negative x value but the same y value no matter what. So what would that look like? If I had a 2 and this was a 4, then if this was negative 2, this would be a positive 4. And that's what's always going to happen. So if any ordered pair and an even function, any ordered pair, if you have x, y, you will have a negative x and a positive y. All right, so what I want you guys to do is, you can take a look at this real quick. You'll see this is negative x, that's positive x, but it has the same y value no matter where I put it. So let's say I put it right there. All right, so what's my x value? My x value is at 9. What's my y value? At a 10. Over here, my x value right here is at a, well, it looks like the table's kind of messed up, but that's actually a negative 9, okay, and it's still at a positive 10. So no matter how that goes, it still reflects across the y-axis. Now odd functions are a little bit different, a little odd, okay? So odd functions are said to be if it's symmetric with respect to the origin. So sometimes you'll see this this little acronym, with respect to. That's what WRT, with respect to the origin. Visually, this means that you can rotate the figure 180 degrees about the origin, and it remains unchanged. All right, so what does it mean to be reflected across or in respect to the origin? No matter what it looks like, there are a certain pattern of x values and y values. So as far as a table is concerned, here's what would happen with an odd function. If I have an x value and a y value in an odd function, I will have a negative x value and a negative y value to match. So here's an example. If I have the numbers 5, 2 on a graph, in an odd function, I would have a negative 5 and a negative 2 on that exact same function. If I had a 4 and a negative 3, what's the opposite of 4? Negative 4. What's the opposite of negative 3? Positive 3. So this is the rule that happens for all odd functions. All right. Now, in a function, if you have f of x, all right, and then you decide you want to plug in a negative x into that original function, it will always equal negative f of x every single time. So what we're going to do is when we find an odd function, I will show you how this rule works. So if you have an original function, and I'll go ahead and do one, cubic function works. There we go. There's a cubic function. Now, if I do negative x into that, if I say, what is f of negative x, that would equal negative x in parentheses to the power of 3, or cubed. A negative times a negative times a negative stays a negative. And hopefully you can see it went from this to now this. So these are not the same. My original function, which was f of x, has now become negative f of x. And that's the rule for all odd functions. All right? So let's take a look at this real quick. All right, so now we got to go across the origin. So we're going to kind of test this rule real quick to see if this works. All right, so we're going to take some random points right here. All right, and that point is at a 6 and a negative 6. So if we were in an odd function, we would be at negative 6 and a positive 6, and it works. All right, let's do this point. It looks like we are at a negative 1 and a positive 3. So we should be at a positive 1 and a negative 3. Positive 1 and a well, I guess, hold on. Oh, my bad. That's not a negative 1. It's a negative 2. Whoops. Negative 2. So we should be at a positive 2 and a negative 3. Oh, there it is right there. Okay, there we go. So you'll notice that all of these points follow the rule of if you have an x and a y value, they become negative x, negative y. So I'm going to select A. Say A is 1. That's an odd function. This is an even function because it's symmetrical with respect to the y-axis. Here's another odd function that's symmetrical about the origin. You can see, now how can you test whether it's symmetrical? Just kind of by visually looking at it. You can kind of see, if I draw this right here, you kind of see if I connect these right here, it goes straight through the origin. Right here also goes straight through the origin. All right, so I'm going to go ahead and select C. And then let's look at this one. All right, this is the y equals x. That's definitely an odd function. Everything is symmetrical straight through the origin. Let's see if we got them right. Oh, yep, all these are odd. Perfect. So algebraically, here's the definition. If you take an original function and you plug in negative right into the x, it's going to become negative f of x for all possible values. Okay, so that's what happens when you are, here's kind of a way of testing whether things are an odd function. Here's x and f of x. Negative x becomes f of negative x. And so you can see this is what it looks like when you're dealing with an odd function. All right. Can a function be neither even nor odd? Yeah, sometimes you can have functions that are neither even nor odd. Absolutely. Okay. So now what we're going to do is we're going to explore this. All right. We're going to go ahead and explore. So let's see here. Let's start with We'll start with equations. We'll start with equations. That one's kind of tricky. Or graphs and tables. We'll start with graphs and tables. That's probably the easiest. So we'll go ahead and start with graphs and tables. We'll figure out if this is even or odd. Now, when I'm interpreting a table, sometimes what I like to do is I like to make the table vertical, not horizontal. So I'm going to go ahead and make a table right next, so I can kind of compare the numbers. Sometimes it's easier for me to see. Maybe you can see things clearly without having to do this, but I'm going to go ahead and do this. And it looks like my domain is -5, -3, 0, 3, and a 5. And my range is 4, -7, 1, -7, and then I have a 4. All right. So what we're looking for is we're trying to look at the table and see if it follows any of the rules, whether they're even or odd. And one thing I notice right here is I notice that the x values are opposite of each other, but the y values are the same. Just like these x values right here are opposite of each other, but these y values, the range is the same. Now this basically follows symmetry, all right, across the y-axis. So let's say you couldn't see that, like you couldn't see, like just with the numbers, that you had the pattern of x comma y, and then it was -x comma y, which basically gives you the definition of what's known as an even function because it's symmetrical about the origin. You could take these points and you could actually put them into Desmos and you could be able to see them. All right, so let's go ahead and let's take these points. Let's put them into Desmos. So if you wanted to, you could make a table. Just make a table and then just call it. Okay, we're going to say, let's go back and take a look real quick. We had what, -5? Here we go. So -5. I'm going to put -3, 0, 3, 5. Okay, then we'll do the corresponding y values, and the corresponding y values were 4, -7. Okay, there we go, 4. All right, -7, 1, -7, and then 4. Okay, so if we zoom out, you can kind of see a pattern that here we have points that go perfectly across the y-axis, and here we have points that go perfectly across the y-axis, and that just happens to be on the y-axis. So you can see there is some symmetry happening across the y-axis. That's why it makes me feel very confident that I'm going to say, hey, this is an even example of an even function. All right. So let's take a look at this table and see if there's any symmetry going on here. So we're going to take a look at it. Just going to make my table. Like I say, I like to look at things vertically. So there's my x. There's my f of x. I'm going to put -6, -3, 0, 3, and 6. I'm going to put -8, -4, 0, -8, -4. Okay. Now here, it looks like I have opposite x values, but I don't have the same y values. These are different. All right, so these are totally different. And over here, I have different x values, opposite x values, but these y values are totally different. So this is definitely not an even function. So what would be an odd function? An odd function would be if we have an x and a y, we're going to have a -x and a -y. So if I had a -6 and a -8, I should have a 6 and an 8. If I have a -6 and a -8, a -6 and a -8, I should have the opposite, which is a +6 and a +8. Well, I don't. I have -6, -8, but I have a +6, but what should be there if that was an odd function? It should be a +8. So this is going to be neither. Now, if you can't see that in a table, sometimes it's helpful if you put it into a graph. So let's go ahead and put it into a graph. All right. So let's take a look real quick. We have -6, -3, 0, 3. All right, let's type over here. -6, we have a 3 and a 6. Then it went -8, -4, 0, -8, -4. All right. -8, -4, 0, -8, -4. And you can kind of see that this is neither symmetrical about the y-axis, nor is it symmetrical about the origin. If it was symmetrical about the origin, then here's what would happen. We would, like I said, we'd have a 6, 8 right there. And then right here, we'd have a 3, 4. Then we'd have an odd function. But we do not have an odd function. Those 2 points right there are in the wrong place for it to be an odd function. So that's an odd function right there. That's an odd function. This is not. So this is going to be neither an odd function nor an even function. Okay. So we're looking at this table right here. It says, according to the table, is it even, odd, or neither? All right. So right now we have opposite x values and opposite y values. Opposite x values, opposite y values. So this looks like upon first inspection it's going to be odd. We're just going to go ahead and take our time real quick, make a table, see if it follows those rules. So we have an x, and we have f of x, and I have a -3, -1, 0, 1, and a 3, and then I have a 4, I have a 2, I have a 0, I have a -2, I have a -4. And here's what it looks like. It looks like if I have an x value and a y value, then I have a negative x value and a negative y value. And that definitely follows the pattern. Because you can see right here, I've got a -3, got a +3. So the x values are opposites, but the y values are also opposites. And that works for this one right here and this one right here. What's the opposite of a -1? +1. What's the opposite of a +2? -2. So this is going to be considered to be an odd function because it follows this rule right here in your table. So we're going to say odd. Now this one's going to be kind of easy. You can kind of see that it is perfectly symmetrical about the y-axis. It splits it right down the middle, so that makes it even. Anytime it reflects across the y-axis, it's considered to be even. All right, so the graphs are easy. The tables, you got to spend a little bit of time and energy on the table, but it shouldn't take too long if you just write things down. All right, last one. We're dealing with even and odd functions and equations, and this is the last thing we're going to be talking about. And it says Jen was asked to determine whether f of x equals 1 divided by the cubic root of x, whether it's even, odd, or neither. So this is where I want you to kind of use Desmos as you're working through it to kind of see if you can figure it out. All right, so I typed the equation into Desmos. This is a rational function, and if you wanted to check to see if this was an odd function, you can see it's not an even function. If you want to check it, just go to a table, and what we're going to do is we are going to type in, all right, you can kind of see it works here. -1 goes with -1, +1 goes to +1, so we got that the whole x, y, -x, -y. So here's what we're going to do. Technically, if I type in a -2, all right, right here, type in a -2, you can see these are opposites. If I type in a 3, and then I type in a -3, you should see that, hey, we got 3, that 0.69, -3, -0.69. So you can test this and see, oh, this is definitely an odd function. So we know that for sure. We definitely know it's an odd function. Now, what we're going to do is we're going to check her math. All right, so right here, oh, there it is. Let's go ahead and check her math. All right, now we have to find the expression for f of -x. So here's the rule for odd functions. If you have f of x and then you have f of -x and you plug it in, you should get negative f of x. That's what you should get. So we'll go ahead and do that right now with this function. So f of x equals 1 divided by the cubic root of x. So what would f of negative x equal? That's 1 over the cubic root of negative x. Now the cool thing about negatives, and you're taking cube roots, you can always take out a negative out of that. So that would equal negative 1 over the cube root of x, which actually is negative f of x. Well, lets us know this is definitely an odd function. But look what she did here. So she did that. She got this. So step 1, she did everything correct. But then it says check to see if f of negative x is equal to f of x or negative f of x. Well, it's definitely equal to negative f of x. But look at her. It says these are the same. But where do we start at? We started with a positive, and that became negative. So I would say she messed up. These are not the same. These equations are... Oh, wait, hold on. Negative is the same as negative. Okay, I see what she said there. Okay, I misinterpreted that. This is the same as negative f of x. But her conclusion was f of negative is even, but it's not even. It's odd. So she actually did all the math right, but she made the wrong conclusion. All right, so Jen's work is correct, but she just made an incorrect mistake in step number 3. All right, that's where she made the mistake, was in step 3, because that's not considered to be an even function, it's considered to be an odd function. All right, so right now, what we're going to do is we're going to take a look at this and figure out whether it's even, odd, or neither. So now we know what f of x is. All right, so now what I'm going to do is I'm going to do f of negative x and see what that is. So how do I do that? I just put negative x like that. I cube it. And then I put a negative x right there, plus 1. A negative times a negative times a negative stays a negative. So now we're left with negative x cubed over negative x plus 1. And that's what I have. So what is that? Did that end up being our original function? No, it's totally different than our original function. But what would negative f of x be? Because if it's negative f of x, it's going to be an odd function. Well, negative f of x would be this. That would be negative f of x. But here I have a negative in the numerator and I have a negative in the denominator. So I'm going to say that's going to be neither. Okay, that's what I'm going to select. I'll select neither. But before I do that, let's go ahead and type this into Desmos and just kind of check it out. So we're going to go over here. Going to go ahead and put x to the power of 3. And then in the denominator, let's see here, delete that. Put x plus 1. You know what? Just by looking at it, you can kind of see that this graph does not fit an odd function graph. It's not symmetrical about the y-axis, and it's not symmetrical about the origin. So just looking at it, you can totally tell it's not an odd function, nor is it an even function. All right, so this is going to be neither. Now, if you get one of these wrong, click right here where it says see step-by-step solution. So you can kind of see that we found that the expression is neither equal to f of x or negative f of x. So it's neither even nor odd. And then they kind of go through the work. Now here's what I want you to write down in your journal. Okay, here we go. Right there. You can pause the video, write this down in your journal. A function of f is even if, when you plug in a negative x, it ends up becoming the original equation, f of x, for every single value of x in the domain. Where as f is considered to be odd, when you plug in a negative x, it becomes a function where you have a negative f of x for every value in the domain. Okay, so make sure you write those down, and that will kind of give you a hint of whether you're dealing with an even or an odd function in an equation. All right, let's do one more. Okay, and we'll call it a day. Woo! Terry was asked to determine whether f of x equals x cubed plus 1 over x is even, odd, or neither. Here is his work. All right, so here's his work. So what we're going to do is I'm going to write down the original function in blue. All right, here we go. So we have f of x equals x cubed plus 1 over x. Now, if we do f of negative x, we plug that in, and it eventually just becomes that again, then we know it's even. So whenever you plug in f of negative x, if it eventually equals f of x, then that's considered to be an even function. But if I plug in f of negative x, and it becomes negative f of x, then that's considered to be an odd function. So let's see what negative f of x would be. Okay, here's what it would be. Ready? I would apply a negative to that. I basically take the whole thing and just multiply it by a negative. That's all I'm going to do. Take the whole thing, multiply it by a negative. So it would be negative x cubed minus 1 over x. That's what negative f of x would equal. So if I eventually get this, I know it's going to be an odd function. So here we go. Let's go ahead and see if we do this. I'm going to put negative x cubed plus 1 over negative x right there. A negative times a negative times a negative keeps it a negative. And then we have a negative minus 1 over x. This is looking pretty odd right here because it looks like these match. So it looks like it's following this rule right here. So let's see what Terry did. Okay. So he did that correctly. Good. He did that correctly. Good. He got that. So it looks like so far step 1, I'm going to put check. All right. All right. So Terry did step number 1 correct. But let's look at step 2. See what conclusions he met. It said, check if f of negative x is equal to f of x or negative f of x. Since x cubed minus 1 over isn't the same, well, it's definitely not the same as the original, so we know it's not even. But it looks like he did not evaluate. He applied a negative to the beginning, but he didn't apply it to this one. So he didn't, when he multiplied that negative, he didn't do it to both terms. So he messed up right here. So since he messed up there, he has the wrong conclusion because this is odd. So the conclusion is wrong, but he messed up in step number 2. That's where he messed up. So before I hit, he messed up in step number 2. So Terry's work is incorrect. He first made a mistake in step 2. Before I select that, I want to go ahead and show you guys that this is an odd function in Desmos. Okay, so let's go ahead. Delete that right there and put plus 1 over x. All right, so remember the rule. You can kind of see it right here. Look, 3, 23 and a third, negative 3, negative 23 and a third, 2, 8.5, negative 2, negative 8.5. You can kind of see the rule right here happening. Negative 1, negative 2, 1, 2. You can see that this is clearly an odd function just by looking at the table and looking at the graph. So, I'm sorry to say this, but Terry, you made a mistake. And it was in step number 2. And that's all you have to do. It takes a little bit of time, takes a little bit of energy, but you know what? This is one of the things where you just don't click on the answers. You look at it, you read it, and you attempt to do the problem the way I taught you. I hope you guys have a great day, and I hope you learned a little something about even and odd functions in equations, tables, and in graphs. Goodbye.